Elements can exist in three states: solid, liquid, and gas. The difference in the arrangement and movement of molecules among the three states of matter shows that there are stronger molecular bonds in solid than in liquid and gas. As gas molecules move freely at random, the bond between gas molecules is the weakest. This is a simulation of solid molecules. So the particles are close to each other in a fixed pattern or in lattice. Okay, L-A-T-T-I-C-E, lattice. Atoms vibrate but cannot change position. Therefore, solid has fixed volume and shape. So they have strong forces of attraction between the particles. Then next we look at a simulation of liquid. Okay, liquid has a fixed volume. It only changes shape depending on its container. So liquid has a weaker attractive forces compared to solid and medium distances between the particles. Therefore, they have no fixed pattern. So liquid takes the shape of their container and particles slide past each other. Gas has no fixed shape or no fixed volume, and gases fill up containers. Okay, we see that almost no intermolecular forces between the molecules. And you can see also there are large distances between particles. Okay, particles fall apart and move quickly. They collide with each other and bounce in all directions. Gas molecules move randomly. Due to repeated random collisions with other gas molecules, constantly change the direction they move in. So the movement is called Brownian motion. Keep in mind what we have just discussed and later try to relate that with the topic that you are going to learn today, which is specific latent heat. Here is a situation. Ahmad measures the temperature of ice. After some time, he notices the ice melts. When the temperature of melting ice is measured, the temperature is the same as the ice. Why is that? That can be explained with the concept of latent heat. Latent heat is the heat that is absorbed during melting and boiling without change in temperature. And we can also say that latent heat is the heat that is released during condensation and freezing without change in temperature. So during the changes in the phase of matters such as melting and boiling, the temperature remains constant, although heat is being supplied continually. Specific latent heat. This is another term that is different from latent heat, slightly different. So the meaning of specific latent heat is the quantity of heat that is absorbed or released. Okay. Point number 3, during a change of phase of 1 kg of the substance, okay, without any change in its temperature. So there are 5 points when you want to state about the definition. So the formula is L equals to Q over M, and Q is the symbol for heat energy. What's the unit? So the unit of Q, which is heat, is joule, and the unit of mass we use kg, kilogram. Therefore, the unit of specific latent heat is joule per kg. We can either write this way or joule per kg this way. There are two types of specific latent heat, which is fusion or vaporization. So specific latent heat of fusion is the quantity of heat that is absorbed during melting or during freezing of 1 kg of the substance without any change in the temperature. And latent heat of vaporization is the quantity of heat that is absorbed during boiling or condensation of 1 kg object without any change in temperature. Let's look at a heating curve. So this is a heating curve. Now, looking at the heating curve from P to Q, there is heat absorbed, and we can see obviously the temperature increases. Look at this axis, y-axis is temperature, so the temperature increases from P to Q. And that means kinetic energy of molecules increases because kinetic energy is related to the temperature and directly proportional. Now from Q to R, there is no gradient. So we say there is no change in temperature. Change in temperature is 0. Then from R to S, the liquid temperature now increases again. Now it becomes liquid. It's already a liquid. So heat is absorbed, temperature increases, and kinetic energy increases. Now we have another flat graph. So here we say boiling process happens because there is no change of temperature. Change of temperature equals to 0 because the gradient is 0, no gradient of the graph. And then from T to U, again you see the temperature increases. Now if we go back to R, we say that R is the situation where the whole solid has melted. Latent heat is absorbed to weaken the bond between molecules, and molecules are released from their fixed position. Remember just now we talked about fixed position, the lattice, and kinetic energy does not increase and constant temperature. And then we look at boiling T. So T is the situation where the whole liquid has boiled. Latent heat is absorbed to break the bond between molecules. Molecules are separated. Kinetic energy of molecules, yes, doesn't increase because constant temperature. What about cooling curve? So cooling curve from P to Q, we can see that the temperature decreases. So here heat is released, temperature decreases, and kinetic energy decreases. Q to R, again flat graph. So what is that? What process happens? So from Q to R, we have condensation process. So at R, the whole of the gas has condensed. Latent heat is released and molecular bond is formed. Molecules move throughout the liquid, so kinetic energy doesn't decrease because constant temperature. And then from R to S, another decreasing in temperature. If you go back to QR, so the process is condensation. Is the process from S to T. From S to T, we see we have freezing process. At T, the whole liquid has frozen. Latent heat is released. So that bond between molecules strengthen. Molecules vibrate around a fixed position. Kinetic energy of molecules doesn't decrease. And we have constant temperature. That is how we explain why the temperature of the melting ice is the same as the temperature of the ice. It's because the heat is used to break the bond of the molecules.